Well, despite the excitement of these flights and all of the heavy work schedule that the astronauts have aboard, they do have to eat and they do have to sleep. And while we're waiting for further transmissions of interest from the spacecraft, and right now they're busy with technical data, if they begin to describe what they saw again, we'll come right back, of course. But meanwhile, Nelson Benton and Scott McLeod at Grumman Aircraft can perhaps tell us something about the mealtime, which will come shortly for the astronauts.
Walter, with our own mock-up flight plan, Scott McLeod is the cook on this flight. And we're using a few non-space rated items, but the food is rated for space, and we have sort of bypassed the main course. We're going on to dessert, which is chocolate pudding. Scott, you take it from there, because you're the chef.
Oh, very well. This is the water gun that's used, Walter. This is what they'll be carrying in the spacecraft. This, although you wouldn't believe it, is chocolate pudding in this pouch. And the technique that's followed is that the top is cut off of the envelope that holds the chocolate pudding. The gun is then inserted in the top. And I'm afraid I'll squirt Nelson if I squirt it here.
Okay.
But the proper amount for the pudding would be about 4 ounces of water. I'll give it a try. That's what I thought.
Back to you, Walter.
You know, I remember I did that once in Mercury. Some people still write me about it every once in a while. During the Mercury program, I tried to play with some space food. I couldn't get the packages open or any part of it done, and I was in bare hands and not in gloves. I don't know how they manage in space. They're doing better, of course, all the time, and I think that Arthur Clark can sort of confirm this for me. As more that we're out in space, the more men become acclimated, if they ever can, to space flight, the more we find that some of the bugaboos disappear in space. And for instance, food. They thought they were always going to have to go for the little bite-sized pieces so that the bits wouldn't fly around. And because of the lack of gravity, they'd have to eat out of those tubes. They wouldn't be able to handle a fork or a spoon. And now they found that there's just enough I don't know what it is, residual gravity or something. I don't know what you'd call it, but they put the food in aspic now, and now they're having one meal a day with a spoon.
But if you have the food sticky so that it coheres and then the crumbs don't drift away, then you can handle it even in zero gravity. But of course, when we start commercial space flight, we will have gravity on our spacecraft because we'll set them spinning, so we'll produce enough centrifugal force so things will stay in the same place. And then we've got to drink from glasses perfectly normally.
And according to that movie you wrote, 2001, we'll have little treads on our shoes so that we stay firmly on the platform at all times. Well, I hope it will be that way, and I hope it comes quickly enough for me to enjoy it. CBS News color coverage of the flight of Apollo 10 will continue in a moment. Certainly one of the great exciting moments of the space program has just been reported from out there around the moon as Tom Stafford and Eugene Cernan swooped within 10 miles of the moon's surface. And although the communication was not too good, reported back in great excitement quite clearly what they were seeing as they passed over the moon. They're now on the way out in their second pass around the moon. We'll drop to within 11 miles of the moon's surface on this next pass, and we'll be back on the air at 7 o'clock Eastern Daylight Time to report it. This is Walter Cronkite, CBS News Space Center.
This has been a CBS News special report, The Flight of Apollo 10, brought to you by Western Electric, manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Next Apollo update on the CBS Evening News with Walter Cronkite. This is CBS. This is a CBS News special report, The Flight of Apollo 10. Brought to you by Western Electric, manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Reporting from the CBS News Apollo headquarters in New York, correspondent Walter Cronkite.
Good evening. The flight of Apollo 10 is going exceedingly well. Although we haven't heard from the spacecraft now for 35 minutes or so, they're on the 14th revolution of the moon, the two of them, the lunar module called Snoopy, the command module called Charlie Brown. They're back behind the moon, and there is no communication with Earth. It'll be another 10 minutes before we get another signal from them. At this point, the lunar module should be out at the high point of its orbit around the moon, its second independent orbit of the moon, away from Charlie Brown, out about 227 miles, and it would be plunging now just about down toward the moon's surface again. We'll be on that downward path as they come around on the right side of the moon as we look at it from here on Earth, come around to the near side of the moon and establish communications again 10 minutes from now. They'll come down this time to about 13 miles. It looks like their orbit is now 13 and a half perhaps miles over that landing site about midpoint in the moon as we look at it right on the equator. Then they will, at that point, at 47 minutes after the hour, 33 minutes after the hour, 7:33, about 31 minutes from now, they will separate from the descent stage of their lunar module and begin the tricky maneuver of climbing back to 69-mile altitude and rejoining the command module called Charlie Brown, where John Young awaits them. That separation involves this. They fire first time in the hole, as it's called, from the descent stage. That's never been done before. It wasn't done on the Apollo 9 flight. And down there, just 11 miles from the moon, they will fire off, leaving this descent stage behind. And with their engine, with the ascent stage, come back to 69-mile altitude and rejoin the command module. The maneuver begins at 7:33 Eastern Daylight Time from now, and it's now 7:03 Eastern Daylight Time, and it will be after 10 o'clock tonight before that maneuver is completed. They will begin the terminal phase of the maneuver at 9 minutes after 10 tonight. The rendezvous should come at 10:54, and the docking about 19 minutes after 11. The flight has gone exceedingly well today, but there have been some heart-stopping moments right after early this morning, around 11 o'clock this morning, after Cernan and Tom Stafford had climbed into the lunar module. They had a little trouble getting their communications going, but then that was all cleared up. It was only temporary. A little later on today, an hour after that time, when they began testing their spacecraft before separation, they found that they could not depressurize the 3-foot tunnel between the lunar module and the command module, and that proved to be a very serious concern and worry, because without the depressurization of that tunnel, it meant that there was added friction set up between the two spacecraft and the possibility of damage to the docking rings absolutely necessary for their redocking tonight. So Houston looked very carefully at that problem, as did the astronauts themselves. Considerable concern about it until they decided that they could go ahead and undock anyway. However, that decision was really left to the astronauts. They were given some parameters beyond which they could not go, some constraints. They had to watch very carefully as to whether there was too much of the movement between the two spacecraft that might damage those rings. When they decided there wasn't, they made the decision themselves on the far side of the moon and separated. And then the first firing of the lunar module's descent stage engine, and that went exactly on time to bring them down within 10 miles of the moon's surface revolution ago. Then Stafford and Cernan very excitedly called up the sights they were seeing. The communications were not too good, and we heard that both of their cameras aboard failed. How many pictures they got before that happened, we don't know. But at any rate, perhaps they got some pictures for us, and we got some voice description of the amazing sights they were seeing. The most important thing, the landing radar, which will have to work for the Apollo 11 spacecraft so that it can set down on the moon's surface, worked apparently exceedingly well. It gave precise readouts to Stafford and Cernan as to their position over the moon. And furthermore, by eyeballing it, as pilots say, by looking at the site, they said they saw no problem for the moon landing. They said it looked even smoother than they expected, although the terrain around there was apparently pretty sensational for them. As a matter of fact, Tom Stafford said that he saw enough boulders to fill all of Galveston Bay. And the first word from John Young, flying overhead 69 miles high in the command module, reporting back to Earth, was that the first words from Stafford and Cernan, well, he said, they're mumbling down there about all the boulders. They've been going through a short period here of getting a bite to eat, presumably, aboard the spacecraft as we wait for them to acquire signal again, coming around this side of the moon. That comes in another 5 minutes now. And we might go back out to Grumman Aircraft in Bethpage, Long Island, where they build this lunar module. Nelson Benton and Scott McLeod are there, and they can tell us something about mealtime, since we're all enjoying it just about now.
Walter, as we reported earlier, we were preparing the dessert. We had a little bit of trouble injecting the water into this space bag that has the chocolate pudding in it, but we've overcome that problem. And the chocolate pudding is ready. You use sort of a toothpaste tube mode to eat it. And it comes to the top, and it tastes like chocolate pudding. Scott, there's something else on this this bag, too, a big pill in the top. Is that a pill, or just what is it?
Well, Nelson, that's not a bicarb. What you do with this pill is when you've finished eating the food, then you take the pill out, break it in half, and insert it back through this tube.
And it's
obviously well, you can't roll the window down and throw the bag out, so you must keep this food in the capsule, and it will begin to smell after a while, and this kills the bacteria inside it.
Sort of a matter of space dishwashing, I suppose.
Well, I guess so, yes.
Well, Walter, the eat period for Tom Stafford and Gene Cernan is just about over now, and they'll be approaching the very critical stage of the flight, the rendezvous with Charlie Brown up above them on a full stomach.
Well, we've been through many of the critical points of this flight now. We got off of the Earth's surface on last Sunday afternoon. We got into the translunar trajectory in good shape, got into the lunar orbit. We've had the first firing of the descent stage of the lunar module. The separation went well, and now we have the important function of getting back to the command module. This is critical because, of course, the lunar module cannot return to Earth safely on its own. It could probably get back into a trans-Earth trajectory, but it could not enter the Earth's atmosphere. It is not protected by a heat shield. It is not meant to fly in the space atmosphere, and it could not fly. So the lunar module has to rejoin the command module tonight, and they've got one more of those close passes over the moon's surface. However, that has now been accomplished once, and some of the fear and the danger regarding such a close passage has now been dissipated. It has worked as Houston and all of the space engineers and scientists were sure it would work. They were able to swoop within 10 miles of the moon's surface, not be seriously affected apparently by those mass concentrations of material under the moon's surface, which cause some deviations in the lunar gravity, and with some concern for the pilots before they tested it this first time. The second sweep over the moon at 13-mile altitude should provide no problems. CBS News color coverage, the flight of Apollo 10, will continue in a moment. Critical maneuvers ahead of the Apollo 10 spacecraft, the lunar module and the command module, depend, of course, on the function of their engines. Bruce Morton at the Manned Spacecraft Center in Houston has a report on those critical engines that the astronauts depend on in both the two modules. Bruce?
Walter, there are three main engines. There's something like 47 in all, but most of them are just the reaction control system thrusters. This is the big one by the spacecraft's present standards, the Service Propulsion System engine. It's the one Apollo 10 used for its mid-course correction on the way to the moon, the one it used to go into orbit about the moon, and I'm sure most important now from the astronauts' point of view, it's the one that they'll use to get TEI, trans-Earth injection, the start of their trip home. It can be fired as many as 36 times. It has 20,500 pounds of thrust. It weighs about 800 pounds empty. I can verify that because we spent some time today trying to push this one around. Over next door to it is the one we've been hearing the most about in the last hour or two, I would say. That's the Descent Propulsion System monitor. The one Snoopy used as Gene Cernan and Tom Stafford swooped away from John Young in the command module and skimmed down to within 50,000 feet or so of the moon. It's also the engine which, next time it's hoped, will land 2 astronauts on the moon. And still next to that, the one that has to take them off again.
We've lost your picture there, but go ahead and tell us about the engine. We saw the earlier picture and know that you're now down to that small one at the end.
Walter, the small one, I'm really kind of fond of.
There we are.
You know, if you...
Oh, we see you again, Bruce.
I'm kind of fond of this little one. If you contrast this in your mind's eye with that giant Saturn rocket that lifted Apollo 10 off the Earth, this is the Ascent propulsion system. Now, the 3 stages of that Saturn have something close to 9 million pounds of thrust, as you know, Walter. This little fella has just about 3,500, and on Apollo 11, it's got to do the whole job of lifting 2 astronauts off the surface of the moon. It's the engine which shortly now Apollo 10 will be using in the final stages of that critical rendezvous maneuver. It doesn't really look as if it had enough power to get from here to the corner drugstore, but it works. The theory about these things is that it's really difficult for them not to work. They've got backup valves in case something goes wrong with the valves. And of course, once the oxidizer and the fuel meet, it's really against all the laws of chemistry if they don't ignite. Walter?
Yes, Bruce, we just have had word from Mission Control that they have established contact with the command module coming around on this revolution of the moon, and they are just trying to establish contact with Snoopy now, who's a little bit behind the command module, sweeping down toward the moon's surface. We've got Mission Control punched in to our system here, and you will hear the communications as soon as we do.
Charlie Brown, Houston, I cut you out at the beginning of the pass. Say again what you're going to say, over. Nothing important. I'm about to lose. I just lost range that went to 320.50 miles. And I'm no longer in voice contact with Snoopy. I think we're just flat out of range. Roger, we copy. I can hear it very faintly in the background. Roger.
It's 320 nautical miles.
Charlie Brown, Houston, it's your computer. We're through with the load, over.
320 nautical miles from Snoopy.
Roger, thank you.
Almost the extreme range that he is scheduled to be in this pass and in the entire flight. The maximum, this comes up to 368 statute miles. The maximum will be 420 statute miles, which will occur in about 10 minutes from now, about 5 minutes from now. And that will be their maximum range. From there on out, they will begin closing again. The command module, considerably ahead of the lunar module. The further out you go in space, the higher you are in making the orbit of any given body, the slower you go in comparison to land speed on that body, and in comparison to any...
I'm just about to lose you there.
I think that was the voice of John Stafford in Snoopy saying he's about to lose Charlie Brown. Charlie Brown had already said that he thought he had lost Snoopy as far as communications go. They're right at the extreme range.
Hello, John, do you read us? Just barely, you guys. Did you stage?
In this simulation,
Houston, this is... Hey, go ahead there. Go ahead there, Dave.
we heard briefly from Tom Stafford reporting to John Young.
Hello, Charlie Brown, Snoopy, do you read? Roger, read you loud and clear now, or weak but clear. read you guys? Hello, Houston. How do you read Snoopy? Roger, Snoopy. Reading you 5-5. Over.
Tom Stafford confirming at Houston.
When you ask Charlie Brown if he's still in track attitude, I can't get the lock on at this distance out here. Over.
Roger, he broke clock at 320 miles on the VHF. Stand by. We'll ask him on his attitude. Charlie Brown, Houston, are you still in tracking attitude for the... Charlie Brown, Houston, are you
I'm at attitude 180, which is where I'm...
Roger.
Supposed to be right now.
Roger, Charlie Brown, we copy. Snoop, Houston, he is in attitude as called for out in the flight plan, a 180 pitch. We got your ascent looks good and your ascent batteries looks good. Over.
This communications is a rather major test of the
Roger,
systems.
if you'll give us your computer, we need poo and data. We have a state vector for you.
Of the systems in this maneuver, they were curious as to how far they would have communications. It had been hoped that the VHF, very high frequency communication link, the voice link between the command module and the lunar module would stretch out all the way to the maximum that they would be separated.
This is Houston.
Some attitude.
It has turned out to be...
This is Houston. We show you loaded TIG incorrectly in T30. TIG is 10255. 0140, over.
Turns out that they do not have voice communication between the two spacecraft and this great distance. They have not had confirmation that they also have radar contact at this distance, tracking contact. You heard John Young in the command module say that he was in the proper attitude for that, but no confirmation that he was actually tracking the lunar module.
That's the ignition time if Charlie Brown has to perform the maneuver in case Snoopy can't.
In these communications...
Hey, how does that look to you?
Looks real fine, Charlie Brown.
In these communications, of course, a lot of this is technical communication, the read-up of computer settings.
Houston, we got the load in. The computer's yours, over.
And timelines for future events.
Roger. Houston, thank you very much.
CBS News color coverage of the flight of Apollo 10 will continue in a moment. And so both the command module and the lunar module have made their 14th revolution around on the other side of the moon, are now on this side of the moon. If we had glasses strong enough, perhaps we could see them passing across the moon. They've just come into sight and are right around the middle belt of the moon, on the equator of the moon. With the lunar module coming down, he now should be perhaps at a height of around 100 miles, a little less than that, as he gets down toward the 13-mile altitude, which he will have reached at 7:33, or around 14 minutes from now. He, at that point, will separate from the descent stage of his spacecraft, and then shortly after that fire the ascent stage engine to come back and rendezvous later tonight with the command module. The only communication we've had from them in the last couple of minutes was Houston talking to the lunar module, Snoopy as it's called, talking about the cameras aboard. Those cameras failed while they were on the first low pass over the lunar landing site, which is a great disappointment to the men on the ground in Houston and to the entire space program. They expected to get some good close-up pictures of the landing site as seen by a spacecraft coming in toward it. One of the principal principal objectives of this mission was indeed to get those pictures, and yet these men aboard the lunar module, Tom Stafford and Eugene Cernan, reported that they'd taken so many pictures, both cameras had gone out on them. How many pictures they got before the cameras went out, we do not know. They were just talking about the problem, and they suggested that on one of their cameras, the still picture camera, the batteries seemed to have gone. In the other camera, there were other problems with the power supply, and they're going to see if they can get them fixed up before they swoop down over the landing site for the second time. The importance of this flight so far has been that in that first pass over the landing site, there seemed to be no reason why the Apollo 11 astronauts in July should not be able to go safely into a landing. The spacecraft systems, the radar particularly, the landing radar, worked well, and for everything that Stafford and Cernan could see, there are no obstacles in the way. In fact, they said that the site looked even smoother than they had expected it to look. As we've been hearing, Gene Cernan and Tom Stafford divide up the workload in that lunar module. Recently, David Shoemaker talked with lunar module pilot Cernan, asked how the two men who fly the LM divide up the work.
You're basically divided in position by what you can reach in a LM, Tom being on the left and myself being on the right. And although we have control systems on both sides of the spacecraft for redundancy, I use mine very sparingly, only because I'm wrapped up in two computers. Tom is basically wrapped up in controlling the spacecraft, in maneuvering the spacecraft to particular altitudes, maneuvering the spacecraft to acquire stars. I handle one computer exclusively on my side and share the load with the other computer in the center between us. These are guidance and navigation computers. We have to align our inertial platform, our gyros, if you want to call them that, to the stars so that we know that we're pointing in the right direction at the right time. Well, this is basically my responsibility, but not without the coordination and teamwork of Tom actually flying the spacecraft while I'm marking on stars. So we're never really running open loop independently. When I'm done with a computer, I'll say, hey, Tom, you've got it, and he'll take the computer and do something else that he has to do to maneuver the spacecraft, while I'll take it and match it with my other computer for redundancy solutions.
We're keeping in touch with Manned Space Center. It's being piped right into us here, and if we hear any more interesting conversations with the spacecraft, of course, we'll punch right into them. Nelson Benton at the Grumman Aircraft plant talked with Dick Bassano out there. He's the chief consulting pilot to Grumman and the man who trained Gene Cernan and Tom Stafford in the lunar module. Nelson?
Dick, in watching the television pictures from Apollo 10, the antics of Tom Stafford and Gene Cernan, we get the idea they're pretty extroverted. Is that the experience you had with them in working on the LM?
Well, I think that Gene Cernan is the more extroverted of the bunch. They're hard workers, of course, but they do enjoy their levity, as we all do. They're typical fighter pilots. When they get a chance to joke a little bit, why, they'll do it. They've done it in the chamber tests.
Did they have any reservations about the lunar module when they first looked at it, either of them?
Well, yeah, Gene, not real reservations. They're of discovery. Say, when Gene first noted that the descent stage doesn't really have the good, shiny outside skin, and you see most of the mylar, he had a few comments to the effect that it looked like Reynolds wrap, same as McDivitt had commented about it. I don't think he has any real reservations to fly it, however. It was just, he was in a jovial mood that day.
How much time have they actually spent in the LM that they will be flying?
Well, actually, in LM 4, the prime crew has only spent about 20 to 25 hours in the actual vehicle. Most of their time is in the simulators, which are pretty high fidelity in it, at any rate.
You spent a lot more time in it than they have, but then that's the way things are designed.
Yeah, we try to get the bugs out of it and before the customer gets the bird.
Thank you very much.
From Houston, we are listening to them update more material to the lunar module, arranging for the staging, which they say is scheduled now for about 7 minutes from this point. That's the point at which they leave the ascent stage behind. When they do, they lose an important source of power to the space men. They're circling the moon. The ascent stage engine, with up to 9,000 pounds of thrust, could be used to put the entire docked configuration, that is the command module and the lunar modules, back into a trajectory toward the Earth. But once they leave it behind, they have gotten rid of that one contingency in case of emergency, and they're left with only their service propulsion system engine in the command module with 20,500 pounds of thrust to put them into that Earth trajectory. As soon as we get any further descriptions from the lunar module, from Tom Stafford and Gene Cernan as they sweep down toward the Earth's surface, we'll be plugging into that, but we haven't been hearing much yet. They're talking engineering right now. They're concerned with getting everything lined up for the most critical maneuvers as far as Stafford and Cernan are concerned yet in this flight, and that's getting back to Charlie Brown, the command module, so they can come home. One of the important features of that rendezvous and docking is going to be being sure that that docking latch works and they can really hook up with the command module. And this was one of the concerns before they separated today, when they had a little trouble with purging the oxygen out of the pressure out of the tunnel between them. Bill Stout and Leo Krupp out at North American Rockwell and Downey can tell us more about that.
Walter, I think first of all we have to draw a line of distinction between capture latches and docking latches. Now, what we see here is the probe coming out the front of our command ship at North American Rockwell and Downey. And there are in the circle, the docking ring, 12 of these docking latches. And Leo has one that I think perhaps he can use to show us exactly what's involved in all this. Leo, what we're talking about here are the docking latches, the hard lock, in effect.
That's right, Bill. These are the docking latches. We have 12 of these around the tunnel area. And when these are actuated, the two vehicles are rigidly attached, and we're in what we call the hard docking configuration. Now, earlier today, when Stafford and Cernan went into the lunar module, John Young cocked all of these docking latches. He retracted them, pulled them back in a cocked configuration, as we see here, so that when the lunar module comes back later this evening and docks, these will be in the right configuration to...
They'll be ready to go.
...to receive the lunar module and to rigidly attach it. You see this hook here comes over this flange here, which is part of the lunar module docking ring. Now, we can simulate the docking by throwing this lever here. We have to assume that the two vehicles have docked in a soft dock configuration where the probe and drogue are mated, but the two docking rings are still 10 inches apart. Then John Young will retract the probe, which will pull the two vehicles together. Now, as the lunar module docking ring comes down, which will be simulated by this little piece of arm coming down, it will trip a lever which will release the docking latch, which I'll do at this time. And you see this lock goes over through a spring mechanism, and the two vehicles are firmly attached. Now,
you can certainly hear that in the spacecraft when all 12 of those go at once, or fewer than 12 for that matter. It's a good loud noise and quite a jolt.
That's right. John will have two cues when the docking latches go. One will be the sound, which is quite loud when all 12 of these go at one time. The second is he has an annunciator on the instrument panel which will go to gray, telling that at least 6 of these docking latches have made it. Now, all we really need are any 3 of these 120 degrees apart to make a satisfactory docking.
1/3 of the way around the circle.
That's right.
A minimum of 3 will hold them that tight.
That's right. All we need are any 3 120 apart. Now, one of the first things John will do after docking is remove the tunnel hatch and go up into the tunnel to see if all of these 12 latches have automatically actuated. Now, in the event that one hasn't, he goes up in the tunnel and he finds one that's still in the cock configuration that has an automatic release. He'll take his felt tip pen, like I'm using here, and trip this little lever, which will manually trip it and allow the latch to make. So he will, one way or another, get all 12 of those latches mated up.
But, Leo, these are not the latches we talked about during the tension earlier today when we were talking about capture latches.
No, Bill, at that point in time, these 12 latches were in the cock configuration or unmated,
And the only thing holding the vehicles together at that time with the probe and the capture latches, which are the 3 latches in the head of the probe which extend through to the other side of the drogue.
But these are the 12 we depend on, Walter, when they come back together later today, the 12 that will hold them firmly together for the return of Stafford and Cernan to the command ship and later to Earth.
They've got just 1 minute to go before the staging, before they drop that descent propulsion system engine, and they are coming now down to their low point, 13 miles above the moon's surface, but they're so busy with engineering details that they're not hearing much description of what, or any description of what they're seeing, but let's listen in.
My attitude looks good. I'm coming up on 270 upside down. And yours is looking good. Babe. That's that last attitude.
Bye-bye.
Stay out of there, babe. That's that last attitude.
Bye-bye.
Should be getting confirmation of staging any moment here.
Danny, next time you want to go.
Animation shows the firing of the RCS thrusters.
And the map is set for a light vehicle. We'll do it this way. Okay, you ready?
Animation just a little ahead of the reports from the spacecraft.
Okay. Son of a bitch. Okay, let's make this burn on the axe, babe.
We're waiting for the confirmation.
Make this burn on the axe.
We see staging. The telemetry reports staging.
Good staging. Let's make it on the axe.
This is Eugene Cernan.
You get in the gimbal lock? She didn't go, huh? Got stage.
Now he says they've got staging. I understand that in Houston Mission Control they get reports by telemetry.
Yep, booze up, babe. Okay, our angle. You didn't lock, huh? Something's wrong with that jar. Okay, roll is 180 and pitch is 233. 233.
These reports from
I'm gonna
Cernan.
put my ball on inertial just to check them out, verify them, too. I can't reach it.
These reports
If you
from
can put mine, you can verify it on the ag.
These are the reports from Cernan.
Snoop, Houston, we show you close to gimbal lock. Yeah, okay, something went wild there on that staging. And we're all set. We didn't lock it. We're going ahead to the auto maneuver. Roger.
Apparently they had some problem in the separation stage.
I don't know. Let's put my ags in inertial, though, to verify that we're at the right attitude, babe. Huh? Put it, okay, just so it's in inertial. Okay, because in case we have to go to it, that's what we want. Let's get that ag. Wait a minute. Gotta get this damn thing. Charlie, how was the stage? Wait till that thing blinks. Charlie Brown, Houston, they got staging. They had a wild gyration, though, but they got it under control, over.
A wild gyration. Boy, at that height, 13 miles over the moon's surface, that's not child's play.
Inertial, Tom? Okay, that's good. Got a lot of time, 7 minutes. Well, I don't know what the hell that was, Dave. Snoop, Houston, you're looking okay for the insertion burn. In a second, I just...
You seem to be all right now.
Yeah, Roger, Charlie. That was something we've never seen before. It was real good. We went to Ags and...
The computer's yours, Tom. I went through P30. Going to P40.
Apparently, when they separated from the descent stage, they got some gyration in the ascent stage where they're riding the lunar module.
I'll tell you what happened there real quick as we come around with this insertion burn. With the attitude deadband, started thrusting out, and the thing just took off on us.
Roger, we copy.
And I could see we're coming up, and we come up to insertion, so I got a hold of it and tried to avoid gimbal lock, and guess I did. Looks like we got a good insertion out of it anyway. And, a good staging out of it, and we're all set to go for insertion here.
Okay, Tom, call 686.
Well, you could hear the tension in those pilots' voices as they were making those readouts. Stafford obviously was terribly busy. He couldn't even...
The computer's yours.
There were no comments from Stafford throughout that operation. We were hearing only from Cernan, who, as a good test pilot, was reading out, as he should have, as the lunar module pilot, the readings.
We're going backward. That's where we want to go.
Well, Stafford obviously...
Okay, there was a moment there, Tom. Well, let's worry about it after we make this burn. I want to make sure the axe is up for it.
They have stabilized the spacecraft apparently, but of course they're not out of the woods yet.
Mark, 5 minutes to the burn. Mark, 5 minutes to the burn, over.
The burn is the firing of the Ascent propulsion system
Charlie,
engine.
we're with you. I think we got all our marbles.
I think we got all our marbles. In other words, Tom Stafford thinks that they're in good shape again.
It's sure coming down to that ground, I'll tell you. I don't know, but I hope we never find it again.
They must be talking of the Ascent stage, which they have now lost.
And I tell you, that was wild, babe, and it wasn't the depth because you were an Ags. That was Ags. Yeah, why deadband? That's where we're going to stage. Okay, babe, I've got good Ags, and everything's looking good. I got the attitude set, so if we have to switch, we'll be all right. Okay, 407 on monitor until the burn. We're at 4 minutes. Okay, 4 minutes. Well, that's hard to do with helmets and gloves on. Give me a monitor, ascent pressure 1 and 2. Let's take another look at it. That's looking good. Engine stop push buttons, all reset, and their board stage reset. Okay? Push buttons reset. X translation. X translation 4 jets.
The SAGs they're talking about is a VORT guidance system.
I'm not reading them, so if they don't make it, you got to tell me, huh? Roger, they're counting down now. Looking good. Charlie Brown. Okay, Tom, if we got less than 170 feet, if we got more than 170 feet per second to go, we're on RCS. Then we'll RCS maximum 55 seconds, but we will RCS. So if we go greater than 170, we're RCS back to our pad Delta V. Okay? Which is going to be right in P40 there. That's looking good.
RCS is Reaction Control System. It's that system of...
And our pad Delta V is 220.9, so if we burn less than 170 feet per second, or if we don't get up to 170 feet per second to go, we'll want to burn it back to about 220. Okay? Let's get over 100, let's get into the 170 feet per second region. Okay, push your inverter number 1 close, circuit breaker.
It's about 2 minutes now into the firing of that engine.
Control, AELD closed.
Reaction control system
down
is
among them again, going backwards. You know that? Look at that grill. That's gotta be probably Diamondback right there. Awful close to see that. Okay, babe, coming up on 2 minutes.
With all of their problems, they're good observers they're supposed to be on this scouting flight. They're taking a look at the ground as well. You can hear the breathlessness of these pilots, though. They're wearing their full spacesuits for these critical maneuvers. And it's not easy to work in them, as Cernan indicated a moment ago.
Okay, 2 minutes, babe. Give it a final trim. Okay, there it is. Okay, my AELD's coming close, Tom. Okay, and verify your inverter number 1 breaker's closed. Okay, at 35 seconds, we want the engine arm to arm. And ping, we're in auto. Going right into the attitude, babe. That engine arm yet to go. Coming up on 112. I'll hit 99 and I'll count you down. Burn time is 15 seconds, so it's going to go in a hurry.
That's the length of time the engine fires, 15
120
seconds.
feet per second, 220.9. 50 seconds, 48. Maybe let's make this one.
This is the one that sends them back out away from the moon's surface, back up to the 69-mile altitude where they can rendezvous and dock again with the command ship.
After armor's on, engine arm, Ascent, X control, and auto deadband mirror. We're set for this attitude on the burn. I'm counting down on 500.
This 15-second burn will increase their speed 141 miles an hour. Both in the command module
9,
are
8, 7, 6, 5, 99, 3, 2, 1, burn. Burn? Okay. 160 to go.
This is the simulation.
134 to go. You're burning. 100 to go. 78 to go. 50 to go. 20 to go. Stand by, Tom. Okay, I'll null them out. Oh, beautiful, beautiful. Charlie Brown, Houston, he got the burn off. We're in good shape.
Oh, boy.
Outstanding. Okay. Congratulations to the Snoopy. -0.3, +0.1. That made me feel better. Call up Verb 82 when you get a chance. There's the egg says we made a good burn. Snoop, Houston, we copy the residual, so that's great. So we got it. Oh, Roger, the burn looks real good. I tell you, we're down here where we can touch the top of some hills, though. Just under cases like this, it sounds like to me you can relay through him, because every time you talk to me, I hear him talking in the background. Okay, hello Houston, this is Snoopy. It shows us in a 46.7 by 11.0. Over. Roger, we copy. 46.7 by 11.0. Okay, Tom, engine arm off. AELD breaker open. Okay, mine's open, master arm off. And inverter number 1 breaker open. Okay, and the RCS, just for record. So it's 80 and 78. Oh, I'll tell you, I thought we were wobbling all over the sky. I'm surprised those residuals ended up where they did. Okay, yaw 180 and pitch down 90.
That must have been some rocky ride they had there for a while. They're now, according to their computer aboard, in a 53.7 by 12.6
Charlie Brown, Houston, can you hear that? Hear them talking when I keep key down here, over?
Which is just about where they're supposed to be.
I thought all of a sudden that was great. Okay, when they start talking, I'll key down here and relay through you, over, till you get them again.
That's Houston speaking to Charlie Brown. John Young.
Right.
Those communications presumably were being relayed to him, and he must have had some bad moments up there, wondering if he was going to have to go through those maneuvers for which he's been training for 2 years, to go down and try to pick them up from their 13-mile high altitude. But now they are on the way back up to his altitude. They come up to within 13...
Charlie Brown, Houston, we recommend for your next maneuver you can load the DAP with a half a degree per second. We see 0.2 now, over.
They'll come up to within about 15 miles below him, below the command module, and then begin the series of maneuvers to actually rendezvous and dock with him. Their next firing of the engines is at 9:32 Eastern Daylight Time. That's an hour and 44 minutes from now. Then there's some more maneuvers, and finally rendezvous at 10:54 and docking at 11:19. We'll come back in just a moment to go out to Grumman Engineering Aircraft and find out just what might have happened out there in those very tense moments as they were just 13 miles above the lunar surface. CBS News color coverage of the flight of Apollo 10 will continue in a moment.
The laser beam, darling of science fiction, exotic laboratory toy, until 1965, when engineers at Bell Labs and Western Electric became the first to put the laser on the job in industry. The job? Piercing holes in industrial diamonds to make thin telephone wire. Today, Western Electric uses the laser to cut material for thin film electronic circuits. We also use the laser to measure and to weld tiny parts for equipment we make for the Bell telephone network. Someday, the laser beam may transmit telephone calls and other data. Someday, you may find yourself talking over one. Western Electric. We make Bell telephones. We also helped change the laser beam from a toy to a tool.
CBS News color coverage of the flight of Apollo 10 continues after this pause for station identification. This is CBS. Apollo 10 coverage is brought to you by Western Electric, manufacturing and supply unit of the Bell system, as part of our continuing coverage of important news events. Now here again is Walter Cronkite.
At its 3,700-mile-an-hour orbital speed around the moon, the lunar module Snoopy, with Tom Stafford and Gene Cernan aboard, is now making its rather slow climb up by comparative speed, slow climb at any rate, up to the command module for the rendezvous and docking a little later tonight. There were some close moments there, the precise details of which we do not know, as they swept within 13.5 miles of the moon's surface. They apparently had some tumbling, or at least some disorientation right after they cut loose the descent stage of their two-stage lunar module. Perhaps our correspondent Nelson Benton and test astronaut Scott McLeod out at Grumman Aircraft in Bethpage, Long Island, can tell us about it. Scott, Nelson, from what you heard on that transmission, what happened?
Well, Walter, I'm afraid that unless I was there, I really couldn't say from the bits of information we got back here. I think it'd just be pure guesswork to try and estimate what had happened in the vehicle.
Well, it did seem to have something to do with their attitude, however, did it not?
Well, I'm unsure whether it was their attitude or it could have been the 8-ball here that was tumbling or something else, depending on how they switched from one computer to the other. I could explain with Nelson how they intended to make that burn, if that would help.
Well, it might. They were talking considerably about AGS, the abort guidance system.
Yes.
Which you might explain to us and how that is plugged in at the given moment. They clearly were fighting the spacecraft in some fashion. Tom Stafford was so busy we didn't hear a word from him, and Cernan's brief communications were certainly laconic.
Well, the abort guidance systems that you were just speaking about is controlled from over in the corner there where Nelson is. I don't know whether you can see it or not, but the computer that does control it is very similar to this one that is the primary system. The burns that they do in the spacecraft, type burn like this, is done rather than using the throttle, which is behind me, and manually going through a burn. The information is inserted into the computer itself, either the primary guidance computer or the backup or abort guidance computer, and then the two astronauts, Gene doing most of the work for the insert, and Tom backing up in case there is a problem and he must do it manually, stand by and wait for the burn to be done automatically.
We don't know yet, I don't think, Walter, whether or not it was necessary for Tom Stafford to override the abort guidance system when that gyration, I believe it was described as, when it occurred. It did occur, I think, right at staging, so that's the point in time that the problem is, but I guess there'll be some head-scratching for some time to come as to exactly what happened.
I imagine not only some head-scratching, but I would think that until there is a very clear readout of what happened and why it happened and how it can be prevented from happening again, that for the first time in the flight of Apollo 10, we see a possible constraint to the flight of Apollo 11. Quite clearly, if there were wild gyrations of this spacecraft tonight, they're in that very close proximity to the moon. They can't tolerate this again. It, however severe it may be, it is far from the normal, and there's going to have to be a great deal of consideration given to what happened tonight. Bruce Morton in Houston has a report on the work going on at the Manned Spacecraft Center during this flight to prepare for Apollo 11. Maybe, Bruce, you've heard something around there that would indicate how seriously they take this problem.
Well, Walter, they take it very seriously, and I think you hit the nail on the head when you said that for the first time something's come up which really could change the plans for Apollo 11. Obviously, nobody here is sure yet what happened either, but they are sure about what they want to do. They want to talk to the astronauts at considerable length, both on the return trip and once they're back on the ground. And they want to monitor all of the electronic data, the various bits of tracking information that come down here. That's a process, as you know, Walter, that takes some time, 2 or 3 weeks usually. So I think it's fair to say that the future of Apollo 11 as a moon landing mission is in doubt now, and it's going to be some substantial period of time before we know, and indeed before the directors of this NASA program know which way it's going to go. This is the first thing like that that's happened. Up till now, it's been pretty much a textbook flight. They may have lost a few photographs, but the moon mappers say they have a lot of those anyway. This, for the first time, is a real serious worry.
Bruce, it is true, of course, that when they blast off from the moon, they're leaving the ascent stage behind on a stable platform on the moon. And if this was malfunction tonight was directly connected with the separation from the ascent stage, then it may be considered, when Houston begins to assess all of the data and gets the debriefing from these astronauts, that they will determine that the solid platform for the ascent stage would negate any such problems of guidance of the lunar ascent stage itself.
Well, that's a possibility, Walter, but we're not sure yet. It could have been an attitude problem, and if it's the attitude in the ascent stage, then it seems to me they're in trouble because you're on the surface and you've really got to start going pretty well straight up.
Yeah, that's right.
At the beginning of that.
Right. I didn't mean to suggest that all was well, because they will have a stable platform, but it is one of the considerations, I'm sure, that will be fed into the mix, as they say.
I hope you're right.
Thank you, Bruce. CBS News color coverage of the flight of Apollo 10 will continue in a moment. Houston has just messaged the lunar module that they already have analyzed the problem when they got that wild gyration at staging, and they believe it was because one of the switches in the lunar module was thrown into the wrong position, a remote control switch it's called. If that analysis proves to be correct, then presumably all will be well in the spacecraft, and there will be no more concern about that particular problem. We'll be back at 11 o'clock Eastern Time for Rendezvous and Docking tonight. This is Walter Cronkite at the CBS News Space Center.
This has been a CBS News special report. The flight of Apollo 10. Brought to you by Western Electric, manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Next Apollo update at 11 tonight Eastern Time.